Alright, so good day, grade 5. So in this video, we're going to talk about new lesson that you need to learn for your grade level. Alright, so before we start, as usual, okay, so let us have the short opening prayer before we start. Let's bow our head into the presence of the Lord. In the name of the Father, the Son, the Holy Spirit. Amen. Lord, we offer you everything we do today, all our works, our joys, and our sorrows. Everything will be an act of love for you. Holy Mary, Saint Joseph, Saint Joachim, and Saint Anne, guardian angel, intercede for me, so that I may be deserved to be helped and saved today and always. Virgen del Pilar, pray for us. In the name of the Father, the Son, and the Holy Spirit. Amen. Alright. So, once again, would like to introduce you to our new lessons, no? Lesson, grade 5. So, this topic, I know that you will be excited to learn this more, no? Most likely, you will be encountering this one in your grade 6 as well. Alright, so anyway, let's start already. Okay. So let us, before we go to our topic, let us try to recall first. Okay, so let us try to recall first. So, what do you recall? Um, what do you recall from the discussion? All right. So from the discussion, or from the meeting that we had last time before we're going to start this one. We encounter uh, multiplication and division of decimal, alright? So we discussed multiplication and division of decimal, which tackled that there are two ways, no? Two ways how to multiply a decimal number and how to divide a decimal number. Okay, so in dividing decimal number, we have the method of long division, isn't it? So that is the first method that we have, the long division, and as well as the second method, which is the fraction form. So I do hope that you are already familiarized how to multiply and divide, decimal number. Now, when we are going to multiply a number, isn't it that there are two ways as well? So the first method is by doing the normal way of multiplication. No? And the second way is the fraction form as well. So, the multiplication and multiplication of decimals and as well as the division or dividing decimals, there is a difference on how are we going to get the quotient and the product of each decimals. No? So, in multiplication of division, um, we said that we should count how many decimal places do we got uh, from the given that you are having, no? Before you have your final product, okay, final answer, you should count first how many decimal points do you have from the given that you are uh, dealing. Now, once you count all the decimal points, that's the time you are going to put the number of decimal points to your final answer. By what process? By borrowing and returning the decimal points. No, correct. That's it po. And from the for the division, no, isn't it that we also tackle that the difference between the two is that for multiplication we are going to count, correct? But in division, the only matter there is the two rules. What are the two rules? The first rule is you cannot divide any number if your divisor is a decimal number. Okay, that's the first rule. The second rule is, what's the second rule? The second rule is if the divisor is decimal, you move the decimal point of the divisor, same with the dividend. Okay, so what if ever that your if ever that your divisor is a decimal number, that's the time you are going to move. You're going to move your decimal point until it becomes until it become a whole number, isn't it? So the rule here is we need to make the divisor a whole number. Okay, so if ever that your divisor is not a whole number, that's fine. You can make, or you can proceed the long division in a normal way without moving any decimal point. Okay, and with that, once you make it as a full number, you borrow the decimal point, isn't it? So it seems like a multiplication as well. Now, so once you have your final answer in your or your quotient, that's the time you're going to return, or you're going to place how many decimal points. But that is for fraction. But in long division, remember, if you move the decimal point already, that's the time that you just align the decimal point wherever you move the decimal point from the quotient, isn't it? Alright, so I do hope that you remember how to multiply and divide a decimal number. Okay? Alright, so with this, we're going to tackle this new lesson. Alright, so but before that, let us try to express this fraction in simplest form first. Alright, so we have this given. We have this given, which is uh, they are five, no, five numbers. We need to find the simplest form or the lowest term, no, for each fraction that are stated. So the first given, we do have 20 over 60. Now, so with this fraction, what do you think is the simplified form or the lowest term for this fraction? Oh, how are we going to get the lowest term? We're going to get the GCF, or the greatest common factor of both numerator and denominator. No? So with that, if you found the greatest common factor, that's the time that you can cancel. Alright, so if you have already the greatest common factor, what is the greatest common factor between 20 and 60? Hmm. The factors of 20 are 20 times 1, isn't it? And for your 60, it could be factored by 20 times 3. Alright, so the greatest common factor for your numerator and denominator is 20. So therefore, we could simply convert this fraction into simplified form or lowest term. So by dividing both numerator and denominator by 20. Correct? 20. Alright, so when we divide it already, what will be the final answer? 20 divided by 20, the answer is 1. 60 divided by 20, what is the answer? The answer is 3. So therefore, we have 1/3. Or, the simplest form, easiest form. If you have the GCF already, isn't it, that you factored the numerator and denominator, if you just found the greatest common factor or the common factors, which are the common factors, if you just saw common factors for your numerator and denominator, you can cancel them out already. No? You could express that one as 1. No? Any number, if you divide it to itself, for example, 3 over 3, the answer will be 1. Okay? Because 3 divided by 3 is 1. Alright? So if you saw common factor, your numerator same with the denominator, you could cancel that one. Alright? So whatever the number remains, that is your final answer. Are we clear? Good. Alright. So next, what do you think is the simplest form for the next number? It is 3 over 30. What do you think is the lowest term for 3 over 30? The factors of 3 are 3 times 1. How about for 30? It is 3 times 10. So the answer is 1 over 10. Correct. 1 over 10. Why? What is the GCF? The GCF is 3. So we divide both numerator and denominator by 3. We divide both numerator. So in that case, this is the GCF. What's the rule a while ago? If you saw common factors for your numerator and your denominator, you just cancel that one. Whatever the number remains, that's the time, or that's the number will be, or that will be your lowest term already. Okay? All right, next. We got 4 over 6. So for 4 over 6, what is the lowest term? What are the factors of 4? It could be 4 times 1 and 2 times 2. Alright. So with that one, let's try ha. Let's try. Let's try. Let's try. So for number 6, what are the factors of 6? It could be 6 times 1. Alright. Or 2 times 2. Alright. So do you see from this first factors, did you see any common factors to each other? 1, of course. But in the end, it will still be 4 over 6. Yes. But how about the other factors? Did you see any factors that are the same from numerator to denominator? There is. And what are the common factors? It is 2. So we could say that the factors of 4 are 2 times 2 over, or divided by 2 multiplied by 3. Alright, so as we said a while ago, if there is no common numerator, a common factor, we can divide it already, or we could cancel them out already. Now, if they are the same, we could cancel or diminish them already. Now, from your numerator and denominator, if they have common, we can diminish, and whatever the number that was left, what are the numbers that was left? It's 2 over 3, or 2/3. Now, whatever the number that was left, that is your final answer. Gets already? I think you are getting it already. Okay? So, for numbers 24 over 8. So, let's try ha. So, for your 24, what are the factors of 24? The factors are 24, 24 multiplied by 1. Correct. How about the next one? It is 8 times 3. Correct. And should be 6 times 4. Correct. How about for 8? It could be 8 times 1. Correct. It could be 4 times 2. Correct. Or it could be 2 times 4. Correct. Alright. So with this one, from this, alright, from these factors, what factors do you see that they have in common? Of course, 1, of course. No, it will still be the same, 24 over 8. But we could neglect this one. How about in this part? 8 times 3 and 4 times 2. Do you think, do you saw something that are the same? From numerator going to your denominator? None. So, we could have 6 times 4 over 2 times 4. Why? You have the factor of 4 in your numerator and to your denominator, and they are common to each other. So, we can diminish. Therefore, the only numbers that are left are 6 over 2. And with that one, knowing that 6 divided by 2, what is the quotient or the answer if you divide 6 by 2? 6 divided by 2, the answer is 3. No? So, you could have simply as 3. Gets? How about 24 over 48? Yes, alright. So, it could be 24 over 48 or 24 times 1. 24 times 1 over 24 times 2. Gets? Alright, so with that one, the common factors are 24 from your numerator and 24 for your denominator. And we could cancel them out. Okay, so what are the numbers that was left? It's 1/2 already. Gets? Alright, so that is 1/2. So I think you know it. You know how to simplify fractions already, no, in lowest term. Gets? Alright. So how about this one? So divide the following. So we are here to divide. How are we going to divide? Please remember this initial K, C, F. K is for keep. T is for change. F is for flip. Okay? So, K for keep. You're going to keep the first term. So, you're just going to write it as it is. Now, C. C is for your operation. We're going to change. Not change. Change what? Change the operation from division to multiplication. Oh, you just change the operation. Then, lastly is you are going to flip. Okay, if you say flip, your numerator will be transferred to your denominator, and your denominator will be transferred to your numerator. So your 2 will go at your numerator, and 3 will go at your denominator. Now gets already, ha? Alright, so with that said, how are we going to multiply fractions? Isn't it that it is numerator to numerator, denominator to denominator. So 4 times 2, the answer is 8. Correct. How about 6 multiplied by 3? The answer is 18. Correct. So with this one, I will be asking you, is 8 over 18 is the final answer? Can I ask, is that the final answer? Could be. Or, we could say that the simplest form of 8 over 18 is, what are the GCF of 8 over 18? It could be simplified by 2, isn't it? So, 8 could be divided by 2. Alright, so it will be 8 over 18 divided by 2. Is 18 divisible by 2 as well? It is divisible, isn't it? So 18 could be divided by 2 as well. So we could divide 18 by 2 as well. So if we're going to divide 8 by 2, the answer is 4. So by 18, if you're going to divide 18 by 2, the answer is 9, of course. So the final answer is 88 over 18, or, don't forget the word or, 4 over 9. Okay? Alright, so with that one, let's go for the next one. So we do have 3 over 5 divided by 2 over 6. So I'll be doing this in a fast manner. So let's have the KCF. KCF. So we're going to keep 3 over 5. Alright, so we're going to change from division, it will be multiplication. If you have F, it will be flipped. 2 over 6, it will be 6 over 2. So numerator to numerator, 3 times 6, the answer is 18. Alright, so 5 multiplied by 2, the answer is 10. So 18 over 10 is still manageable to make it in lowest term. So 18 divided by 2, the answer is 9. Then 10 divided by 2 should be divisible by 2. It is 5. So we divide both numerator and denominator by 2. Correct. So our final answer could be 18 over 10 or 9 over 5. Alright, so no need to, I will be accepting if it's improper fraction. Don't convert it into mixed number already. Though it's fine, but I will allow if it's improper already. Okay? Okay po. So let's have the third one. KCF. So keep, change, we change the operation, we flip 4 over 3. 3 over 4 becomes 4 over 3. So with that, we could have 4 times 4. What is the answer? 16. 6 times 3, the answer is 18. Correct. Alright, so with that one, is 16 divisible by 2? Yes. How about 18? Is 18 divisible by 2? Yes, so we could tell that both of them are able to be divided by 2. So if you're going to divide 16 divided by 2 and 18 divided by 2, what would be the answer? 16 divided by 2 is 8. 18 divided by 2, the answer is 9. So the final answer would be 8 over 9 or 16 over 18. Okay? Alright, so how about 3 over 9? So we do have 3 over 9. We have 3 over 9. We change this one, KCF. We change the operation. And we flip. So it will become 4 over 2. So 3 times 4, the answer is 12. 9 times 2, the answer is 18. And they are divisible by 2. So divide them by 2. So 12 divided by 2, the answer is 6. 18 divided by 2, the answer is 9. So is 6 over 9 the final answer? No. Why? They are still divisible by 3. So 6 divided by 3, the answer is 2. 9 divided by 3, the answer is 3. So the final answer is 2 over 3 or 12 over 18. Okay? Alright, so for the last number, no? So we have 7 over 6. Oh, the question maybe you're asking, why are we here? Instead of getting the new topic. Because this is the practice before you enter the next topic. Really. Alright, so let's have this last example. So 7 over 6. What's 7 over 6? The answer is 7 over 6. You just skip that one. Is it KCF? And you change the operation to become multiplication and you flip this one. So from 3 over 2 it will become 2 over 3. And you are going to multiply numerator to numerator and denominator to denominator. 7 times 2, the answer is 14. 6 multiplied by 3, the answer is 18. Alright, so do they have a common factor? Or are they divisible by 2? Yes, they are. So they are divisible by 2. We could divide both numerator and denominator by 2. 14 divided by 2, the answer is 7. While our denominator is 18 divided by 2, the answer is 9, of course. So our answer would be 14 over 18 or, don't forget the word or, 7 over 9. Okay? Alright, so I do hope that you were able to exercise yourself during this time when we are dividing fractions. Because having fractions in our new topic is one of the important things, no? One of the important things before, in order for us to continue to learn this new topic. Alright, so what is this new topic already, no? Alright, so Sir Jai, what's that new topic? So with that new topic, I prepared pictures for some for you to guess what are the things that you could notice in this picture. Alright, so I want you to look at this picture and think of 3 words that comes into your mind that would describe these 3 pictures. So what could you see in this picture? They are, alright, there is a ball, okay, there's a guy. What can you say about the picture? Okay, think of 3 words. Alright, so maybe you are thinking division. Okay, because there is uh, uh maybe in fraction. Okay, fraction maybe. What else? You balance. Okay, balance. Maybe balance as well as this one, balance. Or if you say balance, they are somewhat what? Equal. Okay, they are equal. They are balanced and they are equal. Correct? Alright. So, if you say equal, they are the same. So, they are ball. They are they are the same ball, isn't it? They are the same ball, but they do have different sizes, isn't it? Okay. Oh, what else? Oh, maybe you have same what? Characteristics or could be, or they are just the same but they do have different value. Okay, or they are the same guy but they do differ with the value that they are having. This wears black and this wears white. All right, so what is this one? All right, so I did prepare as well a random word, and it is a scrambled word. I want you to identify what is this word. Okay. Okay. So this is oat here. What do you think? What word do you think do you have? in the scrambled word? Ah, tell me. Mm-hmm. What? Oat? Okay. What? Alright, so it might be what? Okay. Alright, so it is ratio. Correct. No, it is a ratio. Correct. Or how about this next word? Hmm. Nitropopro. 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 Ah. Nitro. Okay. What else? Proportion. Correct. So it is a proportion po. So we do have these two words, which are ratio and proportion. And with that, our new topic for this day is none other than ratio and proportion. Okay, so are you ready to listen? Okay, so I do hope that you are ready to listen. No, so because this is one of the important things before you go beyond your learnings, no, from your elementary going to your high school. Okay, so it is important to know these things. Okay, all right. So let's have this one already. So our objectives for this lesson is to define what is ratio and proportion. Okay, and we're going to use different methods on how are we going to show the ratio if they are proportion. No? How are we going to uh, show if the two ratios are proportion? Okay? And as well as we are going to use fraction and colon for group of numbers and objects. No? So later on we are going to discuss what are those fraction and colon that we are telling. No? And lastly, we are going to find the missing terms in proportions. Okay, so are you ready po? Alright, so with that one, let's now go to define. No? Let us now define what would be a proportion. Okay, so if you say proportion into your own words, if you heard proportion, sorry, rather ratio rather, no? If we say ratio, what comes into your mind if you say ratio? Mm-hmm. Maybe some of you just have that idea already. Alright, so let us define what is a ratio. Okay, if you say ratio, a ratio is a comparison between or relating of two different things. Or we could say that a ratio is a comparison of two quantities. So it means that you are comparing two quantities. Like just like for example, a while ago, you have the feather and the rock, isn't it? So you are comparing between the two, you're at the middle, no? You have two quantities. What are those quantities? The quantity for the feather, the quantity for the rock. What else? You also have what? The steel and the feathers, no? You have the quantity for steel and feathers. You are comparing the two objects. Or if it's in object, you compare two objects of two things, no? But in math, if we say ratio, more likely we use numbers. So we are going to compare two objects using numbers. Okay? Because sometimes objects does carry numbers. How are they going to carry numbers? By their value. Of course, they always have values. Okay? All right. So that is for the ratio. All right. So next, what if proportion? If we say proportion, what do you think, or what comes into your mind if you say proportion? Proportion is somewhat okay. Somebody would tell equal or what else? Or same. Okay. Alright. So if we are going to tell, we're going to say proportion. A proportion is a statement that two ratios are equal. From the statement itself, a proportion is not what also an expression or whatsoever, but it is a statement stating that you have the two ratios. Yes, for example, you have the two ratios. Let's just, for example, this one. 20, 20 over 25 is equal to 4 over 5. So, we are going to tell that they are equal. Okay? They are equal. Though, if they are equal and they are both ratio, for example, let's just say this is a ratio. Okay? This is a ratio. Now, if they are ratio, if they are ratio, and if they are equal, if they are equal, we could tell, we could tell ha, we could tell that these two ratios are proportion. But, no, but, if these two ratios are not equal, for example, they are not equal, they are ratios they are ratio, they are both ratio, correct. But if they are not equal, we cannot tell or we cannot say that they are proportion. We could simply tell that these two ratios are not proportion or they are not proportion. Only that one. Okay? So again, if it is proportion, a proportion is a statement that these two ratios or the two ratios are equal to each other. Okay? So there are two ways. How are we going to write the proportion, or how are we going to write the proportion? There is two equal fractions. Okay? Two equal fractions. Or using a colon. Colon. Ha? If we say colon, these are the indications of like two dots. A line in the top and in the bottom. Okay? So that is the colon. Right? That is what we call colon. If you saw a colon between two numbers, for example, you just saw 20 colon 25, this is a ratio. Okay, so in ratio as well, please take note that in ratio we could write it in a colon form, colon form, or in a fraction form. So how are we going to make it in fraction form? Your 20 will be your numerator, 20 over 25. Okay? So that is how are we going to make it in fraction form. Okay? So this is, if you're going to read this one, if you're going to read these numbers, we're going to read these numbers, the 20 over 25, yes, that is in a fraction form, and we used to tell it as 20 over 25. But if it is ratio, we are going to read it, no? We're going to read it as 20 is 2. The colon is read as is 2. Alright? Is to 25. 25. Okay? Alright? Alright. So, if we are going to read as a whole, it is read as 20 over 25 or 20 is to 25 as 4 is to 5. Okay? Okay po. Alright. So, I do hope that you are now getting what is a ratio and what is a proportion. Okay? So, this is a ratio. You're just going to compare two quantities. Okay? So, what is a proportion? Proportion is statement. Statement of what? If the two ratios are equal, we could tell that the two ratios are proportion. But if they are not equal, take note if they are not equal, can we tell that the two ratios are proportion? No. So what are we going to tell it? They are not proportion. Okay? It seems like if you do bad thing, the statement in there is that you were wrong. Okay? You were wrong because you did a bad thing. But for example, you did a right thing. You do good. A statement telling that if you do right thing, you're doing good or you are good. If you are not good or you are not equal, okay, you make the wrong thing, you're not equal, the statement is you are not good. you are bad. Okay? You are not proportion or you are not good. Gets? That is a statement. Okay? Proportion is a statement. Ratio is comparison of two quantities. Gets already? Okay po. Next. So this is an example of a ratio. Okay? Let's have this example. So Horton harvested 20 fruits. How many fruits? 20 on his farm. Okay? So we do have 20 fruits. Let's just put 20 fruits. Okay? Alright. In his farm. Six of this, six of this, six of these fruits are apples. Alright, so six of these fruits are apples. So, we could tell that from your 20 fruits, you have six apples. Alright, and the rest are bananas. Alright, so if I will be asking you, if you have six apples from your 20 fruits, how many bananas do you have? You count. 1, 2, 3, 4, 5, 6, 7. How many? You have 14, correct. Because if we are going to add these two fruits, or the apple and the banana, you have 20 fruits. Correct? Correct, ha? Sige po. Alright, so let's have this one, ha? Okay, so the question is, what is the ratio between the number of apples to the total number of harvested fruits? Oh, what do you think? What is the question? What is the ratio of what? The ratio of the number of the apples, okay, to the total number of harvested fruits. So, with this, no, let's have this already. So, your first term is the ratio between the number of apples. What is the first? What is the first given that was stated? The number of apples. I will be erasing this one. What is the ratio? This is the one that we are going to find. Ratio. Ratio. Okay? So, if you are going to say ratio, it could be in colon or in fraction, isn't it? So, what is the ratio between the number? It is unknown still. Okay? You have two terms, two quantities. You say ratio, you are comparing two quantities po. Okay? So, what is the ratio between the number of apples? Okay? This is two quantities. Between the number of apples. So, what given that was stated first? Number of apples. Okay? Correct. Alright. So, next is to the total number of harvested fruits. Next is total number of harvested fruits. Okay? Alright. Number of harvested fruits. So, let's just say it is A and HF. Okay? Harvested fruits and apple. Alright. So, this is the one that we are going to find. Okay? What are the ratio between apple and harvested fruit? So, if we are going to uh, write it down in a ratio form, how are we going to write it down? Oh, what is your first term? What is your second term? This is your first term, ha? Take note. This is your first term. This is your second term. Okay? Hmm. What is your first term? What is your second? Alright? Oh, what is your first term? First term, if you see first term, that is the first given that was stated. What's the first statement? This is A, of course. Alright, so A is to HF or harvested fruit. Because harvested fruit is the second one that was stated, no? So harvested fruit. That is the ratio between the two. Or it could be A over HF, correct? Mm. If you are going to find what are the values of this one, what's the value of the apple? The value is 6 apples. So we could write 6 is to, what's the value of HF or harvested fruits? It is 20. So you could write 20. 6 is to 20 or apple 6 over harvested fruit 20. Okay, so it could be in colon and fraction form. Gets? Alright, so this is in visual form, ha? Visual example. So you could have 6 apples, okay, 6 apples and 14 bananas. Okay, so from your 20 fruits, 20 harvested fruits, you have 6 apples. If you are going to write it down in ratio form, this is the one. So you have 6 apples and 20 fruits. Okay? Okay po. So, we could write that one in a ratio form. What's the ratio form? It is 6 over 20. Okay? That is 6 over 20, ha? Okay po. Are we clear? Alright. So, let's go already, ha? Okay. So, if that's 6 over 20, do you think that this is the final answer? This is the ratio? Could be in this form, isn't it? 6 over 20. Or in a colon. What is in the colon? It is 6 over 6 is to 20. Correct? But, do you think that this is the final answer? 6 over 20 in fraction form or this one? This is the final answer? Of course, you should find as well as the lowest term. What is the lowest term? Oh, a while ago ha. If you are going to find the lowest term, you should find the GCF or the factors of 6 and 20. What are the factors of 6 and 20? Those are 3 times 2 and 10 times 2. So what are the common factors that you could see in your numerator and denominator? 2. So these are the common numerators, the common factors. We could now cancel them both. And what are the numbers that was left? 3 and 10. So you could just write 3 is to 10. Okay, gets? Alright, so therefore, the lowest term of 6 over 20 is 3 is to 10. Okay, 3 is to 10. That is the final answer, or we could write it down in a uh, colon form. Okay, so take down notes ha, or take note of this one. We could tell that the final answer in here is 3 over 10 or 3 is to 10. Okay? Okay. So those are for the ratios. Those are for the ratios, ha. Alright, so how about in fraction, Sir Jack? So if we're going to talk about fraction, if we're going to talk about the proportion, this wait if we're going to talk about the proportion already, so let's just say you have the ratio of 6. Let's just say, let's continue the given a while ago. You have 20, you have 20 fruits, that's equal. You have 20 fruits and you have 6 apples. This apple, and you have 14 bananas. Okay? You have fruits, you have 20 fruits composed of 6 apples and 14 bananas. Alright, so in proportion, um, a while ago, you were asked that what is the ratio? Ratio of what? Ratio of apple and fruits, isn't it? Oh, that's the one that was questioned to you. 6 and 20. So it is 6 over 20. Alright. So that is the ratio of the apple and the fruits. Now, what if, this is the one, uh, what if, uh, Sir Jai, if we were asked, what is the ratio of, you were going to be asked, what is the ratio of the number of the banana between the total number of fruits? Hmm. What is the ratio of the number of banana to the total number of harvested fruits? So the ratio of that one would be 14 is to uh, 20. Okay? So, in ratio, here's the thing you are comparing two quantities. Okay? And in ratio, there is what we call uh, two. Two given things in ratio. So what are those two given things, Sir Jai? So here's the thing, Let's just erase this one. So if you have, let's just say, okay. So if we say ratio, there is what we call as ratio to whole, and ratio for parts. Okay. So if we say ratio by whole and ratio by parts, what is ratio by whole? A while ago we have 20 fruits and we have 6 apples and 14 bananas, isn't it? All right. So from the given itself, as you will notice, what is your whole? Your whole is the 20. Why? That is the totality of the two givens. What are your two givens? 6 and 14. The apples and the bananas. Okay? You cannot have the 20 fruits if you don't have the numbers of apples and bananas. If you only have the apples, you cannot have 20 fruits. Correct? If you only have that 14 bananas, you cannot have 20 fruits. Correct? Because there is missing. So it means A and B, or apple and banana, is your part. Is They are your parts. Okay? And your 20 would be your full. Okay? Okay, so if I will be asking you, uh, what is the ratio of the whole for the total number of apple between the total number of uh, fruits? So it will be the ratio of apple is to fruits. Oh, this is 6 over 20, isn't it? Alright. So how about, what is the ratio between the total number of banana between the total number of the harvested fruit? So it will become 14 is to 20. So this is ratio of the whole still. Why is it ratio of the whole? Because you are comparing your parts towards to your whole. Okay? You are comparing your parts with your whole. Okay? So it seems like in your body. Isn't it that in your body you have body, for example, you have body. For example, this is your body. Pardon with my drawing, And this is your body. For example, pardon. Alright, there you go. Okay. So, for example, this is your body, no? So, what do we have? Oh, let's this way. This is your circle. This is your body. Okay. Alright, so let's just say this is your body. So, what parts of the body could you give me? So, you have your hands, you have your feet, you have your knees, you have your shoulders, you have your neck, you have your elbow, isn't it? You have your chest, isn't it? You have your waist, you have your tummy, you have your head, isn't it? So, this is the thing. So, in your totality, in your whole body, that's why we said, we call it as whole body. So, if we say whole body, you are composed, or the whole body composed of parts, no? Parts. These are the parts, isn't it? But if we are going to say whole, if you are going to say hula, that is your body. Your body is the whole, isn't it? But if I just ask you, what is your hands? What is your hands? That is only a part of your body. Gets? Okay po. So, hands, knees, toes, shoulders are just part of your body. And your whole body is the total form of your figure. Now, in your ratio, you have two ratios, the whole and the parts. Now, if you compare your parts to your whole, this is what we call as ratio to whole. Now, what is ratio by parts? Now, if there is a question, if there will be a question, there will be a question. It's like, what is the ratio? Ratio. What is the ratio of the total number of apple between the total number of banana? Oh, so what did you notice? You compare two things just within the parts, isn't it? You just get the ratio of the two parts. Oh, the whole or your 20 is not included, isn't it? So you just got the ratio of your parts. Okay, so the ratio is only relying to the parts, no? So with that, if you have the parts already, what are the ratio? This is 6 is to 14. Correct. Correct ha? What is our first term? Our first term is the apple. So let's try. Let's put first term. Okay? Because that's the question. The question is, what is the ratio between the total number of apple? Or what is the first given? Apple. Between the total number of banana. Or what is the second given? Banana. Alright. So what if, this is my second question, what is the ratio? Isn't it that this is the ratio of the apple to banana? So 6 is to 14, or we could write it down as 6 is over 14. Okay. This is the one ha. What if I ask you, what is the ratio? Ratio of what? What is the ratio of banana is to apple? Okay. What comes first? The first is banana. Again, what's the question? What is the ratio of the total number of banana between the total number of apples? So if you will notice, the first given that was mentioned was banana. Second is the apple. So with that, what is the ratio between the two parts? They are parts, ha? They are what we call as ratio by parts. Now, what are the ratio, or what is the ratio between the banana to the apple? It is 14 is to 6. Correct. Or we could write it down in a fractional form. It is 14 over 6. Okay? So these are the fraction form. Alright, so um, with this one, I will be copying. Alright, so this one. Let's just say this one. There you go. Alright. So what if a while ago you just mentioned that the first um, term was apple, the second term was banana. They got the ratio, which is 6 and 14, correct? And in fraction form, it is 6 over 14. And for your second question is, what's the ratio between the banana, between the total number of apples? So this is your first, and this is your second. Alright, so with that, the ratio is 14 is to 6. Or we could simply tell that 14 over 6. Alright, so we have two ratios, isn't it? We have two ratios already. Now, can we tell that they are equal? Is 6 over 14 is equal to 14 over 6? Are they equal? Are they? No, they are not equal. Why? 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 What is the value of 6 over 14? If you are going to compute that one in your calculator, what's the value? The value is, you could use your calculator right now. I will be waiting. 6 divided by 14. The answer is 0.428. Let's just write 5, 7, 1. Until 1 only, ha? Is equals to, what's the value of 14 divided by 6? Let's try. 14, write it in your calculator, 14 divided by 6. The answer is 2 point what? 3. Unlimited, isn't it? Alright, so let's just try, let's just put in that case. Now, I will be asking you, are they equal or not? They are not equal. Of course, it has whole number, and this one, you have 0 whole number. Of course, they are not equal. Now, can we tell that they are proportion? We have two ratios, isn't it? We have two ratios already. Are they equal? No. Can we tell that these two ratios are proportion? No. They are not proportion. Okay? Proportion. They are not proportion. Why? Because proportion should be, they should have, if we say proportion, it should be that the two ratios are equal. Correct. So, if you are going to uh, have an example of two ratios that are equal, what are the two ratios that are equal? So, let's just say 6 over 20 a while ago. These are the ratios of the whole, isn't it? So, this is your apple, this is your fruits, harvested fruits. Or you could just input that one as apple is to fruits, isn't it? Remember? Okay. So, what's the lowest term of this one a while ago? The lowest term is 3 over 10. Correct? Now, this is a ratio. Isn't it? It is apple over F. Correct? Alright. So, how about this one? Let's just say this one. 3 over 10 is apple and fruits as well. Now, if you are going to have the value of these two ratios, let's just say 6 over 20 is equal to 3 over 10. Now, tell me, what is the value of 6 divided by 20 in your calculator? 6 divided by 20, the answer is 0.3. How about in your 3 divided by 10? What's the answer? It is 0.3. Are they equal or not? They are equal, correct, no? So, can we say that these two ratios, they are two ratios, they are two ratios. Can we tell that these two ratios are proportion? Yes, correct. We could tell that they are proportion. Correct. Get? Oh, another example for proportion. What if I will be giving you I have the ratio of uh let's just say 20 20 brand new shoes of Adidas. And I just found uh 40 shoes in total. So for example, this is the store. Okay, this is store, ha. Just imagine, there is a store of uh, shoes. Okay, shoe. Okay, for example, this shoes, shoe store. Okay, so you entered into that shoe store. Okay, so you just entered that one to your shoe store. Now, this is my question. Um, what is what if you just found that there are 40 shoes inside? 40 shoes, ah. You just found that there are 40 shoes inside. Okay? Then 20 of them are brand new. Brand new. And 20 of them are stocks. If you say stocks, it is not really old stocks. Or let's just say old stocks. If you say old stocks, these are the items that they have in that stores, no? But it's old, okay, compared to the brand new ones, new stocks. All right. So if I will be asking you, let's just put your 40 shoes are shoes, okay, and your brand new is B, and your old stock is O. Now, if I will be asking you, what is the ratio between uh, what is the ratio between the brand new shoes between the total now what's the ratio between the total number of brand new shoes and the total number of shoes? So your brand new shoes is 20 and your total number of shoes are 40. Okay, so you have a ratio already. No, you have a ratio. Okay, so it could be 20 over 40 or 10 is to 20. Could be. Okay. Or you could also have what? 5. I'm sorry. 2, 1 over 2. Could be? Oh, alright. Now, let's just focus first in your 20 is to 40. 20 is to 40. Now, this is your ratio for the total number of brand new shoes and the total number of shoes. Now, what if your manager, or what is the manager asks you, what is the ratio between the total number of old stocks to the total number of shoes? What is the number of old stock? It is 20 as well. And what? The total number of shoes are 40. Correct. Now we have as well the ratio of this one. Okay. What? How are you going to identify if what if the manager asks you? Does the two ratios are proportion, or do they have the same proportion? We can write it in fraction form. 20 over 40 is equal to 20 over 40. Are they equal? Are they equal? They are equal because if we are going to divide, you try 20 divided by 40. The answer is 0.5. 0.5 or 1 half. And as well as for the other side, it's 0.5. Now, that is how we could tell that these two proportion are these two ratios are proportion. You have two ratios that should be in equal. What if, this is a quick example, what if you have the ratio of, I think you are getting now what is the ratio, what if you have the ratio of uh, 3 is to 13, and the other ratio is, let's just say, let's just say this the one, this way. You have this way, 9 is to 13. This is your first ratio, for example, and your second ratio is 27 is to 39. I will be asking you, no? Is they are both ratio, isn't it? They are both ratio. This is a ratio, and this is a ratio. Now I will be asking you, are the two ratios proportion? Are they proportion? Are they proportion? Oh, you just write it down in a fraction form. 9 over 13. Are they proportion? Oh, and 27 over 39. Are they proportion? Oh, you try in your calculator. 9 divided by 13, 0.69. Let's just say 0.69. 23 is equal to, how about 27 over 39? 27 divided by 39. What's the final answer? 0.6923. Let's just say up until 2. Okay, so they are equal. So they are proportion. So aside from this one, I am happy, I am glad to show something else, on how are we going to know, or how are we going to find whether the two ratios are proportion. There are methods, no? So in our objective, there are methods. So you will be knowing that one for the next topic that I'll be sending, which are the methods, how to identify, how are we going to identify if the ratios are proportion. Okay, so I hope that you learned about ratio and proportion. So I'll be tackling about, the next one is the methods. But how are we going to find if the ratios, two ratios are proportion to each other? Okay? So with that, thank you, grade 5 once again, and see you in the next video. Bye!